All right, so now we're going to talk about rational exponents, which I've actually already touched on in the last lesson, so this first part should be pretty easy for you. Let's go back to what I started with. I gave you a radical, and I told you that, for an example, that if you had the cubed root of x to the 7th, that you could write that as x to the 7 divided by 3. Okay? Now, I gave you only ones that worked out and actually divided out, didn't I? But on this one, we're going to learn that this is converting from radical to rational exponent. The definition is like this. If you have the nth root of a to the nth power, that is a to the n divided by m. This is also true if you had the nth root of a all to the nth power on the outside. Those all mean the same thing. So if I gave you 49 to the 1/2 power, the bottom number is your index, so that means it's the square root of 49 to the 1st power. Remember, there's an understood 2 right there. You're not supposed to put it, but I wanted to show you where it was. So the square root of 49 is 7. If I gave you 64 to the 1/3 power, that's the cubed root of 64 to the 1st, which is just 4. To review negative exponents, I assume they're thinking that you know the negative exponent rule by this point. I think you learned them in 098. Y'all went over your power rules. So just a quick review of the power rule. If you have a to the negative m power, that's the same thing as 1 over a to the positive m power. So if I gave you 25 to the negative 1/2 power, I would first change that using this rule, that is the same thing as 1 over 25 to the positive 1/2 power, and then use that 1/2 exponent, recognizing that it follows this. This can work either way, so I can go from rational exponent to radical or from radical to rational exponent. This is an equal sign, so it's all fluid through there, right? One can lead into the other one. So this would be 1 over the square root of 25. The understood 2 is out here on the radical, and then the exponent of 1 is right there on the 25. I'm not showing those now. I showed them up here. So this would be 1/5. This one's a neat trick. If I give you a fraction to a negative power, and I've asked you to write it in radical notation and simplify, the first thing you should do is you should flip the fraction. If you flip the fraction to be 9 over 1, the exponent will become positive. So that's like 9 to the 1/2 power, which is simply the square root of 9. So anything to the 1/2 power is the square root. If it's to the 1/3 power, it's the cubed root. But here I gave you one that was to the 7/3 power, so it was the cubed root of that to the 7th power. Let's do one that's a little opposite this. What if I gave you 81, actually I just did that over there, but I'll do this one too, to the negative 1/2. So that means it's 1 over 81 to the positive 1/2 using your negative exponent rule from your last math class. So that's 1 over the square root of 81, and the square root of 81 is 9. Any questions on any of that so far? Okay. So these directions say write the expression in radical notation and simplify. 8 to the 2/3 power. The bottom number is your index on your radical, so it's the cubed root of 8. And you can do it this way, but it's not going to help you if you do it that way, so you're going to use the other rule that I gave you up there that says I can actually take that squaring and put it outside after I cube root it. So those all mean the same thing. The cubed root of 8 is what? 2, and I would have 2 squared, which is 4. This is always best to do this form of it rather than this one, because I knew I could cube root 8, but if I had left it here, I would end up with a cube root of 16, and I could not do that. And that's not the simplest form. This is the simplest form. Okay, so it's always best to put the exponent outside after you take the cube root of it. Okay? Okay, what about this problem? Negative 9 to the 5/2. So this would be, the bottom number is the index on the radical. So that would be the square root of negative 9 to the 5th power. Can you take the square root of a negative number? No. So this is either, I don't know how they're going to say it, but I would say it does not exist. So on page 383 in your workbook, the next example says convert each expression to radical notation. Assume all variables represent positive real numbers. So we're going to start with a rather simple one. I've got y to the 2/3 power. It says convert it to radical notation. And you just assume, if it tells you to assume that all variables represent positive numbers, then you don't have to worry about anything being negative where it's not supposed to be. Okay? So if those directions are in there, you're good to go. So this would be the cubed root of y squared, or the cubed root of y all squared. Those mean the same thing. I'm pretty sure this is the one that they're going to want to see, because it's not helpful to me to put the 2 outside. I can't take the cubed root of y, whereas here I could take the cubed root of 8, so it was helpful to me to put the 2 outside. Questions?
Back to the 8 to 2/3, or 2 over 3. Would that still, even leaving it cube root of 8 squared, wouldn't that still be 4?
Oh, it would be. I kept saying 16, didn't I? It's been a really long day. Did I say 16? I apologize. Yes. I'd give you a Reese cup, but I ate them all. Yes, it would still be 4. You're absolutely right. There are some cases where, not on these, but there are just some cases where it's easier to simplify it first. I always do this too because if this number gets really big inside here, it's just harder to think about. So sometimes that number could be huge. Not if you're squaring it. I apologize. Yes, it still would be 64. No, I really did that on purpose, Ronnie. Yes, just checking. I'm struggling up here for some reason. All right, let's look at another one. I won't make a mistake on this one, I hope. All right, 5. Well, do we need to do any more like those? Since I goofed that one up, or I said that one wrong. I did it right, but I said it wrong. Are we good on that? Okay. Let's do another one with a variable in it. So 5z to the 1/4. This is one that's commonly missed because students think that the 5 is also raised to the 1/4 power, but it's really only the z that is. Does everybody see that? If the 5 were raised to the 1/4 power, there would be parentheses around it, around the 5 and the z, and the 1/4 would be outside the parentheses. So this would be 5 times the 4th root of z. And it's z to the 1st, and you don't put first powers in your answer. I showed it up here on one just so you could see where it went, but it's not something that you utilize when you're doing the problems. All right, let's go the opposite way. Let's take something that is in radical form, like the cubed root of t, and let's write it in rational exponent form. So what's the exponent on the t? Anybody? 1. So that number will be your numerator or denominator of your irrational exponent. Which one? Numerator, that's right. Okay, so it'll be t to the what power? 1/3. Very good. All right, what about the 5th root of c squared? So that'd be c to the what? 2/5. Okay, any questions on those? All right, now we're going to review all of our rational, all of our power rules, but we're going to make them applicable to rational exponents. So all of the power rules that you learned in 098 or whenever you learned your power rules are applicable also to rational exponents, not just to integral exponents. So if you have, and what I'm going to do is just write them over here, I think. So if you are multiplying like basis, a to the m times a to the n, you keep the base and you add the exponents. This is also true for rational exponents. If you are dividing like basis, a to the m, I tell you, let's do an example below each one. So if I gave you x to the 2/3 times x to the 4/3. You're multiplying like basis, so the rule says keep the base and add the exponents. 2/3 plus 4/3 is 6/3, which is 2. So your answer to that would be x squared. If you are dividing like basis, you keep the base and you subtract the exponents. Your example would be if you had 5 to the 3/4 divided by 5 to the 1/2. You'd keep the base of 5 and do 3/4 minus 1/2, which would be 5 to the 1/4 power. So you're just subtracting, that's a minus sign, but it's just not stretching out very far. Subtracting the exponents. Your power rule says if you have a to the m all raised to another power of n, you simply multiply the exponents, a to the m times n. So if I had p to the 3/5 all to the 1/3 power, you would have p to the 3/5 times 1/3. And then you just multiply, and so you would get p to the 1/5 power. If you had a power of a product, so you had a times b all to the nth power, you take each factor and take it to the nth power. So it'll be a to the m times b to the m. Your example is if you have c to the 1/3, d to the 1/2, all to the 6th. That means that you would do 1/3 times 6 and 1/2 times 6. Is that what that means? Because that's a power to a power, isn't it? So it would be c to the 1/3 times 6, d to the 1/2 times 6, which would be c squared d to the 3rd. And then the same thing for power of a quotient. A over b all to the mth power means a to the m over b to the m. Your example is if you have 25 over b squared all to the 1/2 power. Ooh, what does that mean? Well, I would have to take 25 to the 1/2 power and b squared to the 1/2 power, which would be times. The 1/2 power means square root. So the square root of 25 is 5, and then this would just be over b, because the 2's would cancel. Those are some really good examples that you can fill in that chart there to go with your rules. I like this chart a lot. These problems can get really intense. They take lots and lots of practice. Does anybody still need that last problem up before I scroll back up? We're good? Okay. So we'll just do a few, which we've already done one of each kind over there, so that's handy. That should be good for you. But we'll do a couple of others. Let's see. What if I gave you Oh, I know one thing we need to review too, and they didn't put it in the chart, but I want to review it. So one more. Anything to the 0 power is 1. Anything to the 0 power is 1. That's standard. There is mathematical justification behind it. I'm not going to go into it. You just need to know if it's something to the 0, it's 1. Okay? So that was one of the first ones I was going to do. If you had 4x squared all to the 0 power, it doesn't matter what's inside here. If it's all raised to the 0 power, your answer is 1. Now this one's different. What if I had 6y to the 0? What part of it's raised to the 0? Just the y. So this is 6 times 1, isn't it? Which is what? 6. So the answer to that problem is 6. Okay? And I reviewed the negative exponent rule for you earlier, where you have to just make it positive by moving it to the opposite place in the fraction. All right, so let's look at one a little more difficult. So if I had a to the 2/7 times a to the 3/7 all over a to the 1/2. You got a lot going on here. So you're going to take it one step at a time. Simplify this a to the 2/7 times a to the 3/7 first. You're multiplying like bases, so what do we do with the exponents? Look back at your rules. What do? You add them. So 2/7 plus 3/7 is 5/7 over a to the 1/2. I do not know what this is. Oh, I think I'm pressing a button. Sorry. Now I'm dividing like bases. So I'm supposed to keep the base and do what with the exponents? What's the rule say right there? You subtract them, right? Nobody's wanting to do this because they're going to have to either use their fraction button. 2/7 and 3/7 adds to be 5/7. Okay? So what is 5/7 minus 1/2? I didn't bring my good calculator. So we'll have to get a common denominator. It'll be 14. So that'll be 10/14 minus 7/14. So I believe that the answer is a to the 3/14. Is that what y'all got? Did anybody do it with their calculator? Let me see your calculator. My brain is slow tonight. I know it's right, but we're just going to make sure. Yep, that's right. 3/14. Okay. Let's look at this one. 36 mn. Now the n is raised to the negative 1/2 power all over m to the negative 4/3 all raised to the 1/2 power. Always write your answer with positive exponents. You never ever leave negative exponents in your answers. So your goal is to get all your m's and your n's together and simplify your exponents as much as possible. I would start inside here simplifying. You can start by applying the 1/2 power to everything. You can do it either way. You can still, I've worked problems like this both ways. You'll get the same answer at the end. I think simplifying inside here is the best. So the first thing I'm going to do is I'm going to get rid of these negative exponents. So I'm going to move the n down and the m up. 36. That m is still there. This m to the negative 4/3 comes up and becomes positive 4/3. Over, and the end of the 1/2 comes down. Notice it's positive 1/2 when you bring it down. Now I'm going to simplify that m times the m to the 4/3. That's multiplication of like bases. So you're going to keep the base and add the exponents. This is 3/3, right? Isn't 3/3 the same as 1? That was m to the first, right? So I just put 3/3 because I got to add them. So this will be 36 m to the 7/3 over n to the 1/2 all to the 1/2 power. Now I've simplified as much as I can inside there. So I'm going to come down here and I'm going to apply the 1/2 power to everything. So this will be 36 to the 1/2 power, m 7/3 to the 1/2 is 7/6. How'd I get that? Power to a power you multiply, right? So I'm applying the 1/2 power to everything. And then 1/2 times 1/2 for the n would be n to the 1/4. They actually want you to stop here. No, we have to do one more thing. What's the 36 to the 1/2 simplify to? 6. So you had to go one more space. These are hard for me because I don't know where they want me to stop. So I'm kind of looking at an example they've done here, and it looks like that they stopped here. But this could be written in radical form. So I could ask you to write it in radical form. I don't know why I would do that, or why they would do that, but you know, they could ask you to. But I think that's where they're going to want you to stop. All right, any questions? At the bottom of page 380, it talks about when radicals are considered to be simplified. If you could find that video, that's probably a really good one for you to watch. The radicand cannot have a factor raised to a power greater than or equal to the index. The radicand does not contain a fraction. There are no radicals in the denominator of a fraction. Now they don't go into how to simplify all of them at this point, just that those things need to take place. Oh, that's the next section, isn't it? Oops, I got a little ahead of myself. Sorry. So we'll pick up there with that thought the next night. Okay, any questions?